Hello everyone. In this video, I'm going to use the reference 1 to 5 of circle to do some examples for you. In using the reference 1 to 5, what you need to do is to get the skills required. The first skill you need to use is to use the proper reference and also write the proper reference. And second, since most of the references here are related to right angles, and therefore it's important for you to think about the use of Pythagoras theorem. Now, let's start with the first example. Example 1. You have a circle and the chord AB, O is the center, and COD is a straight line, and C is the midpoint of A and B. Angle OBC is 28 degrees. Part A, you are finding angle BOC. Angle BOC can be found by 28 degrees. If we know this angle and you know it's 90 degrees, then we can use angle sum of triangle to find it. But to present it properly, you first need to say, since AC is equal to CB, which is given, then you have either you write OC is perpendicular to AB, or you can just write what you want. That is, angle OC boy is 90 degrees. Okay, and what's the reference here is the line joining center to midpoint of chord, perpendicular chord. So you need to write line joining center to midpoint of chord, perpendicular chord. Okay, and now for angle boy OC plus angle OC boy plus angle O boy C is 180 degrees. The reference is angle sum of triangle. Okay, make sure every time you write the reference on that line, you need to write the original form, okay, including all names of angles or names of the sides and the original format. Okay, don't try to use angle BOC equals 180 degrees minus 2 remaining angles. Okay, it's not suggested to do so. And also, it's better for you to do the substitution to be clear and make less mistakes. And then you'll know that angle boy OC is actually 62 degrees. Okay, now for part B. For part B, you need to find angle boy dot O. Angle boy dot O is here, and whenever you have a center here, you actually have isosceles triangles automatically. So there are two ways to do so. One, you can make use of angle boy OC. You found it in part A, such that the sum of these two equal angle is 62 degrees. Or you can use the angle sum of triangle again in triangle boy C dot to obtain the answer. Okay, so I will opt for the first method. Since O boy is equal to O dot, which is the radii of circle, and thus angle O boy dot is equal to angle O dot boy, is the base angles isosceles triangle. Now you write angle boy O boy dot plus angle O dot boy equals angle by OC. Okay, remember to write the original form. Do not just write 62 here. Is the exterior angle of triangle. And here you can write what is wanted. Here is you need an angle by dot O. So you write 2 of the angle by dot O equals 62 degrees. And thus you know angle by dot O is 31 degrees. Okay, so this is example 1. Now example 2. Example 2 is a circle with points A by dot lying on the circumference. O is the center, and AB produced and OD produced meet at C. You have CD 14 cm, OA, that is the radius, 20 cm, and A by 24 cm. And you need to find the length of OC. Now, most of the time you may think of to use some method to find the whole length directly. But sometimes you need to use the sum of two shorter lengths or the difference of two lengths to obtain the results. And since I know that is the question is about the use of perpendicular line, so I will suggest to start in this way. Okay, I draw a perpendicular line to AB from O, so that, say I let it be M, so that AM and MB is 12 cm. And then the use of Pythagoras theorem help you to find the length of OM. And since OD is also the radius, that is 20, you have the side of OC, OM, and thus you can find the length of MC. After the subtraction, you will get the length of BC. Okay, so for any extra point you include in the figure, the new kind of drawing, you need to mention in your content or in your working. So let's write down. What I want is the perpendicular line, so I let M be a point on AB such that OM is perpendicular to AB. Okay, this is what you create to the figure. And once you create it into the figure, we have a certain result. Then AM is equal to MB, and is half of 24 equals to 12 cm. And what's the reference here? Is the perpendicular from center to chord bisect chords. Okay, this is the result. The result is to bisect a chord AB. So we write the reference here. It's a bit long. It's okay for you not to write the relation and the reference on the same line. Perpendicular from center to chord bisects chord. Okay. Now, in triangle OAM, we have OA square equals to OM square plus AM square. It's the Pythagoras theorem. And you can do the substitution, or you can just skip this step because it's too easy to follow. 12 square. And you know that OM is actually 16 cm. Okay. Now, you should find out that I write this kind of thing, right? And actually, it's good practice to write what triangles are you referring to. Okay, as to the reader, it's clearer, and it's better for the reader to trace what kind of steps that you are presenting and which triangle is referring to. Okay, so it's a good practice to include this kind of writing. Okay, as in geometry especially. Now in triangle OMC, Then I have OM square plus MC square equals OC square, and the Pythagoras theorem. And since OD is not yet mentioned, so I will have OD equals OA equals 20 cm. That is the radii. And now you can do the substitution. You can have 16 square plus MC square. You can write say MB plus BC square, or you can do it afterwards, I don't mind. And it's equal to OC. OC is OD plus 14, or OD plus DC. Okay, so you have 16 square plus MB is 12, so we have 12 plus BC square, and it's equal to 20 plus 14, that is 34 square. Okay, and although you will form a quadratic here, but then as long as you're finding the length, you know the negative number doesn't make sense at all, and so you can directly find the result of BC. To get it, you have 34 square minus 16 square, and then you take the square root. Okay, positive square root of course, and then minus 12, so you get Boise is actually 18 cm. Okay, so this is example 2. Okay, one more example in this video, example 3. Example 3, you have two chords A, B, and CD are perpendicular to each other here, and they meet at N. OM is perpendicular to AB, then you know that AM is equal to MB. AB is 8, OM is 3, and N is the midpoint of MB. So I mark something like this first. And first of all, you need to find the radius of the circle as well as the length of dn. To find the radius of circle is simple, because you have, as long as you have AM, you have OM, then using Pythagoras theorem, you can find the radius OA. Okay, so let's find it out. Since OM is perpendicular to AB, which is given, then we have AM is equal to MB, and is equal to half of AB, which is 4 cm. Okay, and what's the reference? The reference is perpendicular joining from center to chord bisects chord. Okay, and since OM is 3, you have 4, then the radius of circle is actually 5. So OA square equals OM square plus AM square, which is the Pythagoras theorem. And OA is 5 cm, and that is the radius of the circle is 5 cm. Okay, now part B. After you know the radius is 5 cm and you need to find the length of dn, and we haven't made use of the chord CD, then and also n being the midpoint of M and B. Let's get some idea before we move on. We have the radius, which can be used later on maybe, and AM and MB is 4, so we have MN 2, NB is 2 as well. Then you may think of, we actually don't know the chord CD, right? If we know the length of the chord CD or half of it, then we can find the length of DN through subtraction. And as long as we want to find the length of CD, you should think of perpendicular line drawn from center, because we can just find half of the length and we can use Pythagoras theorem. And in particular, in this question in particular, you get a rectangle here, so that when MN is 2, then you know maybe this point is P, then OP is also 2. OM is 3, then you have PN is 3 as well. Now, together with the radius of circle, when you consider triangle OCP, then you will get the length of PC, and hence the length of DP, and then you can find the length of DN. Okay, so I create some point here. So we let P be a point on CD such that OP is perpendicular to CD. Then we have CP is equal to PD. Okay, it's the same reference, perpendicular, joining from center to chord bisects chord. Then we draw some conclusion of what we have found here. So note that you do not actually need to prove whether OMNP is a rectangle. You just need to state it, because it's too obvious. Then we have several things to work on. We have PN equals to OM, which is 3, and also we have OP equals to MN equals to half of MB, which is 2 cm. And also we have OC equals to OA, which is 5 cm, which is the radii. Then we can use Pythagoras theorem on triangle OCP. So CP square plus OP square is equal to OC square, Pythagoras theorem. And to save time, or to save space, you know that OC is 5 and OP is 2. So you got 25 minus 2 square. So the CP is root of 21. And that's why you are asked to find the length of DN correct to 1 decimal place. Okay? And since we have CP equals to PD, so we can have, therefore, DN plus PN. PN is 3. We found that already. DN plus PN is equal to CP. And so DN is actually root of 21 minus 3 cm. Okay, this is the exact length, and if you want to find the result that meets the requirement, DN is about 1.58 cm. Okay, so I hope these examples help you understand the use of the references and the importance to relate those questions with Pythagoras theorem. Okay, there are more questions coming up. Stay tuned, and thanks for watching.